Boom, this is Blue Dolphin with the Hoplite Security Channel, and we're going to be getting into the HacktheBox RouterSpace. Let's go. Welcome back, everyone, to another HacktheBox machine. In this video, we're going to be covering RouterSpace. This was a very interesting machine that required me to do something that I had just never done before, and I appreciated that. So a summary is that we're going to emulate an APK package and proxy it at the network layer, enumerate and discover rate command injection within the network traffic, and it's over an API, and from there we're going to exploit a pseudo version via a CVE. So what does this look like? Well, from the enumeration phase, we only have two ports open, 22 and 80, fairly straightforward attack surface. So for our initial foothold, we will download an APK, which we find on the website, and spend a ton of time trying to emulate that APK on Linux with the HacktheBox tool, which will be included in the comments down below. It was very difficult and I ran into a lot of issues. For user, we're going to set a custom Android network setting that allows us to create a custom listener on burp, proxy the request where we find our command injection, and we can use repeater to repeat that request over and over until we figure it out. For the privilege escalation, it's just a simple pseudo version, and there's a CVE for a heap overflow. That's it. Let's get into it. Jumping right into things here, we're going to start off with phase one, where we're just going to perform, as usual, our enumeration against the target. And then from here, we're going to realize we have two ports open, investigate those ports, and look into the downloaded APK file, and then that'll kind of conclude phase one. So you can see here that our initial scan shows we have two ports, port 22 and port 80. Let's jump over to the website and see what we're working with here. Landing on the website here, you can see that we initially have two obvious things. That's going to be get start now and the download button in the top right. If we click get start now, nothing really happens, but if we click download, sure enough, we get an APK. And this is where things get difficult, because trying to take this APK and emulate it on a Linux machine can be a little time consuming. We can tell it's just downloading here, but I will be using HacktheBox to help with this. There we go. I'm going to go ahead and move the RouterSpace into our working directory. And this was a very short enumeration phase. That concludes phase one. Jump into phase two next, where we're going to take a look at this APK and kind of learn how to exploit it. See everyone in phase two. Jumping right in here into phase two, let's take a look at our APK here, which first we will start off with some more obvious techniques such as running strings. However, you can see there is obviously too much. So we could try running head, we could try running tail, and we don't really see anything here that's going to be of great help. Now, I have gone and set up HacktheBox, which is the Android simulator, the Android emulator, and that was a bit of a process. I will have links in the comments down below for how to install that and set it up. But for now, I am just going to launch HacktheBox from the interface here, since I've already installed it and set it up. All right, to be honest, I'm not sure why this isn't working, but after hours, I wasn't able today to get my emulator HacktheBox working again. So I've just spun up the request here, but essentially just open HacktheBox and install the APK with ADB tools, and then you open it and you click check status. And it's just this router application, and the router application will send this request right here. And this request is very simple. So we have a post request that's posting to API v4 monitoring router dev check device access. And you can see the user agent is RouterSpace agent, because that's of course the APK or the application that's sending this request. And it's a JSON application of type of 21 length, and the host, this is key, is routerspace.htb. So you have to update your etc host file to actually say routerspace.htb. Okay. What we'll do from here is we can start messing around and trying things. Like we want to start looking for command injection. in a simple request like this. I'm using repeater, and you can see here it actually errored out when I did this ID, which was quite interesting, but maybe if we just send the word ID without a pipe, and we're just looking for error-based command testing, but that didn't work. But if we come in here, we can do pipe ID, and you can see here we successfully have command injection. So the next thing we can do is go for a reverse shell. However, it's always good to test your connections or your command injection capabilities by just sending a ping back. The way we'll do this is I'm just going to call TCP dump over interface ton0, which has to run as sudo, and then we're going to run a ping command from our command injection vulnerability. The way we'll do this is just by going ping. Oh, excuse me there. 1010 14. Let's see, .5. Send this. And you can see immediately that we're getting lit up over here. So we are able to do a ping back. So the next step would be to try a reverse shell. So we go netcat -nlvp. We'll do port 6363. And now we'll just look up reverse shells for bash. Let's grab one of these bash reverse shells here. We'll drop this in as the payload, changing just our port to 6363 and our IP address. We'll send this, check our listener, and it didn't work. So usually in a situation like this, we're looking for some type of SSH key deployment on the target or reverse shell, and the reverse shell isn't working. So what we're going to do is we're going to switch over and do some SSH business here. And the way we will do this is we will generate an SSH key locally. So let's kill the listener. We'll do SSH key gen. And we'll do -t RSA. We already have an SSH key, but it's going to overwrite it. Wonderful. Now we will jump into our SSH folder. And we're going to copy our public keys. So I'm going to cat the public key. Copy this. And I guess what we probably want to do first is see if we can actually create files on the target. So the way that we'll do this is let's start off with an ls/la command. Now we might have to play around with quotes to get it to work. Nope, it worked right away. And our SSH key should be, what directory are we in actually? Let's just do a print working directory command. And okay, so we're gonna have to back up a bit to get into our target machine. So let's go ls. We need to figure out what users are on this box then. So let's just go back a couple directories, see what we got. Oh. We'll check the home directory and you can see we have user Paul. All right, what does user Paul have in his directory? He has, well, I don't know what, but not an SSH directory. So let's do ls-la. And there's a lot of information here. And I'm just looking to see again if he has the SSH directory, which he does right here. Brilliant. So what we'll do is we'll just check what's in there. And we're looking for an authorized keys folder, which you can see, wonderful, we do indeed have. So we want to get our key in there. And the way we'll do this is going to be I guess we'll do echo. Let's just try getting our key in there right away. Now, I believe this is where it's gonna get tricky with the quotes, but I believe we'll have to do a single quote. Ooh, not what I wanted to do. Copy our key. And then we're going to close the quotes over Kali. And now we're going to, we want to do 2 greater than signs, because if we do 1, it'll overwrite, but we actually want to append. And this is going to indeed be for appending the file, which of course will be located in this area, which is homepol.ssh authorized keys. The authorized key folders is what's going to allow us in. Hopefully this works. Don't entirely have my hopes up, but let's see. I don't think this worked, but let's see. Let's go SSH pol at 10.129.227.47. And I don't, oh, looks like it worked. There we are. All right. Well, we are in as user. So that concludes this phase, phase 2. We're going to be jumping into the next phase, which is phase 3, where we're going to exploit and get to admin. See everyone in phase 3. Jumping right into phase 3 here. We are on the box and we're going to be looking around for that initial privilege escalation. However, unfortunately, it seems like I don't have a stable shell because I cannot type at the moment. Here we are. It looks like I'm back and it's working. We can run our commands. Wonderful. So first thing we want to do is try and get linps uploaded in our target here. This is just going to help with enumeration. So I'm going to spin a server here. We're going to use wget to grab our file over at 10.129.227. No, sorry, our local computer at 10.14.5, port 8000, and it's called linps.sh. And it is trying to connect, but it doesn't seem to be working, and it's just kind of hanging there. So this makes me think that they may have somehow blocked connections, because we also know that the reverse shell didn't work. So that's quite odd. We could try opening IP tables, for example, and seeing if maybe there's a rule here we have to block. However, it looks like we don't have permission to open to list tables. So what we could do in this case is we could try using base64 to decode linps and then just copy the base64 version and upload it, or use something like nano or vi if they will work. Vi does work, nano does work as well, and that's great. However, we can also do some manual enumeration. So we can just search up Linux privesc guide. And there's going to be a lot of guides here from, regarding to OSCP, which if you haven't done it, highly recommend it. It's an absolutely fantastic course and exam. So we can see here what they're looking for. So they're looking for, so we can quite literally just go through one of these guides. Now, alternatively, what we can do is, as opposed to going through that long guide, we can also just jump over to linps and take a look to see what it's looking for in the first place. Over on the release page here, you can download the bat file, the .sh file. I guess bat is for Windows, but we can look through it and kind of see what we have, what it's looking for. But one of the things that it tends to look for first is anything to do with sudo. And we can see here if we do sudo -l, that's not going to work because we need Paul's password. Well, we don't know Paul's password, but we could do, for example, a sudo version, take this version, and just simply look this up. And this is going to be key, especially if you're doing something like the OSCP. You're going to want to know to check sudo versions. We can come over here and you can see that we immediately have an exploit, which all the credit was given to the qualities research team. Let's see what this does. This GitHub page doesn't really say much about the CVE, but looking at this, we can see it is indeed a heap-based overflow in sudo. So this is interesting. So let's take a look. Looks like the qualities, yep, we know the qualities research team discovered this heap overflow. And there's not much else to it. I guess there isn't much to say other than, unless they showed us their code and how they overflowed the heap. Oh, looks like they do have some details here. All right. So it looks like if sudo has to be executed to run command in shell mode, either through the S option or the I option, Then it looks like the command line argument user args at line 864 to 871 is highlighted here. And if a command line argument ends with a single backslash character, then they get all sorts of weird behavior to do with a null terminator and incrementing lines. So this is a very... Okay, so it looks like the attacker has to control the user args buffer, which can be overflowed. They then have to control the size and contents of the overflow itself. Okay, the attacker can then write null bytes, which I think was through the backslash, and that helps them, and that will help reach the buffer on the stack as you find your entry point and you overflow to depending where you want to go in the memory address, likely to the stack indicator. And you can see here they have an example here saying that the following command allocates a 24-byte user arg buffer, a 32-bit byte heap chunk, and overwrites the next chunk size field with 2 bytes, and then that is where the payload would go. Interesting. So they've also put it out here on the counter, which is nice, or this little timeline. All right, well, I guess let's give it a shot. We obviously aren't going to write our own heap overflow, maybe not in an easy level challenge, maybe in more of a difficult challenge, but you could do it if you wanted. However, we're going to give this exploit a shot by downloading the code here. So we have the exploit.c code. Let's copy this. And I'll just create a file on the target and call it exploit.c. Oh, not exploit.ca. That's no good. And I have everything uploaded here, as you can see. So we're going to go ahead and run make. And it has already created the file. Whoops, sorry, I think I had a lapse in video coverage there and I wasn't recording. But what I did was I just uploaded makefile, exploit.c, shellcode C. I ran makefile, it created everything. I ran exploit and it didn't work. Well, that's because I have to use the // and we are now, of course, user root. And we can get the flag. That's it. This was a very fun machine. I really appreciated it. It was a lot of fun trying to get the Android emulator to work on Linux and then having to capture that network traffic by pointing this APK router towards Burp Suite, which I apologize again that I couldn't capture. But other than that, happy hack the boxing. See everyone in the next video.